So today we're going to go ahead and talk about geometric sequences. Now, geometric sequences are sequences that increase or decrease by a fixed product or ratio. So if we look at the first one, if we have 1, 2, 4, 8, and as it continues, that common ratio is equal to 2. Now with this, you can go ahead and see that each of these are increasing by 2, but if you didn't see that, all you'd have to do is take an, any number in the sequence, and an minus 1, the one before it, and divide. So 8 divided by 4 is 2, so is 4 divided by 2, and 2 divided by 1. They're all equal to 2. With this, it's just really important to remember that you take the higher value in sequence divided by the next one. So it has to be 8 divided by 4, and 4 divided by 2, and 2 divided by 1. So if I look at the next sequence that I have here today, it would be 10, 30, 90, 270, and that continues on. And if you notice this, if I take an divided by an minus 1, n minus 1 just means the previous term. Any term divided by the previous term is going to go ahead and give you a ratio of 3. Or in this case, r is equal to 3. All right, so let's do a couple more. So if I'm looking at one that is decreasing, so 4 to 2 to 1 to 0.5 to 0.25 and so on. Do know it does help to write these as a fraction. So this is exactly the same thing as saying 4, 2, 1. 0.5 is the same thing as 1/2. 0.25, excuse me, is the same thing as 1/4. So with this ratio, it may not be as obvious to see with this, but it's still the same idea. An divided by the previous term. So in this case, it would be 2 divided by 4, which is 1/2. That works at any other point. If it was 1 divided by 2, also 1/2. And then 1/2 divided by 1 is also equal to 1/2. So make sure that you divide in the correct order. What you will see that is if the sequence is increasing, the ratio will be a number larger than 1. The absolute value of the ratio will be larger than 1. And if the number is decreasing, then the absolute value of the ratio will be between 0 and 1. Now, sometimes you'll get an alternating sequence as far as signs. So if I have 1/3, comma, negative 1/9, comma, 1/27, 1/81, you'll see what I mean by this is the series sequence alternates between positive, negative. We're still doing the same thing here. It is just n over n minus 1. So with this one, we're going to have to do this with fractions. So that's going to be negative 1/9 divided by 1/3, or negative 1/9 times 3/1, negative 3/9, or negative 1/3. So the ratio for this one is equal to negative 1/3. So the general sequence for the first term, and the first term again is A1 would equal A1 times the ratio 0 times. And then the second term would be A2, which is still A1 times the ratio 1 time. And the third term would be A3, to a to the r to the second. Or the general piece with that is an is equal to a1 times r to the n minus 1 power. So as you can see, this is the explicit rule for a geometric sequence. And this will always be the case for this. Now, if you want to go ahead and write a recursive rule, which again is not nearly as useful, but it's just a to the n is equal to the previous term n minus 1 times whatever that ratio happens to be. So we want to make sure we are able to write the explicit rule, which is just a to the n is equal to the first term times r to the n minus 1, and the recursive rule, which is a to the n, which is equal to a to the n minus 1, the previous term, times r. So the first step in doing this is to go ahead and look at the sequence. So let's look at the sequence 9, 18, 36, 72. All right, so the first thing we're going to go ahead and label this. So the first term in the sequence is a1, which is equal to 9. We need that. And then the next thing we want to do is find the common ratio. And we do that by just dividing 18 by 9, which in this case is equal to 2. So I know r is equal to 2. So I have r is equal to 2. I have my first term. So now I can go ahead and write my pieces. So I know that the explicit is going to be a to the n is equal to 9 times 2 raised to the n minus 1 power. And then the recursive rule is a to the n is equal to a to the n minus 1 times 2 when a1 is equal to 9. You could also write this as an is equal to 2 times a to the n minus 1. We're going to go ahead and look at a few more of these. Okay, so let's go ahead and look at the ones that we had in the very beginning. So remember that the first term here in all of them is a 1. We're going to need that. Now, we already talked about r, but we're going to go ahead and mention it again. All we're doing when we find r is just 2 divided by 1. So therefore, this ratio is 2. For the next one, 30 divided by 10. So that gives me a ratio of 3. 2 divided by 4, and it has to be in this order, and this ratio is a fraction, so that ratio is 1/2. And then the last one is negative 1/9 divided by, which means multiply. So these are all of the same sequences that we looked at in the beginning of the lesson. So let's just go back and make sure we label everything. Remember, the first term in every sequence is a1. And the ratio, r, which we need to find all of them, is just one term divided by the previous term. So in this case, 2 divided by 1, which gives us 2. The next one is 30 divided by 10, which gives us 3. 2 divided by 4, and it always must be in this order, and that does give us a fraction ratio, which is 1/2. And the last one, which was negative 1/9 divided by 1/3, which means it's negative 1/9 times 3. So that ratio is negative 1/3. So I shrunk the top, but you can probably still see it. The recursive formula that we have here is just a to the n is equal to the previous term, n minus 1 times r. And remember, with the recursive formula, you do need to state what a1 is. So the recursive here gives me a to the n is equal to a to the n minus 1 times 2, or a to the n is equal to 2 a to the n minus 1 when a1 is equal to 1. So my recursive formula here is a to the n is equal to my ratio, which is 3 times a to the n minus 1 when a1 is equal to 10. The next one, a to the n, is equal to my ratio, which is 1/2, times the previous term, n minus 1, when a1 is equal to 4. And the last one, an is equal to negative 1/3 times a to the n minus 1, the previous term, when a1 is equal to 1/3. Now with the explicit rule, I just need to know that an is equal to the first term, which in this case is 1, times the ratio to the n minus 1 power. So the first term here is 10, my ratio is 3, raised to the n minus 1 power. My first term is 4, my ratio is 1/2, raised to the n minus 1 power. And the last one is a to the n is equal to 1/3 times the ratio negative 1/3 to the n minus 1 power. Now we need to go ahead and simplify two of these because they have the same base. So if I look at the second to last one, a to the n is equal to 4 times 1/2 raised to the n minus 1 power. 4 is the same thing as saying 2 squared. The 1/2 I can write as 2 to the negative 1 power to the n minus 1. So that is 2 to the 2 times 2 to the negative n plus 1. And the rule for exponents is when you are multiplying, bases are the same, you add those together. So then this is actually going to equal 2 to the negative n plus 3 power. The next one, a to the n is equal to 1/3 times negative 1/3 to the n minus 1. Well, there's a little trick with this. I'm going to write this as 1/3 times negative 1 to the n minus 1 power times negative 1/3 to the n minus 1 power. This is something you're going to see quite often, where is if this is a negative ratio, you want the negative 1 to be raised, and that is the indication that is your alternating sequence. Now, 3 is to the 1/3 is to the first power, excuse me. So what I want to now do is add 1 and n minus 1. So this just gives me 1/3 to the n times negative 1 to the n minus 1 power.